All right. Well, welcome back. So this is going to be another AI engineering video since the self-managed network one is on pause. Also, the guide seems to have some kind of error in it because I can't get my VPN to connect on my phone. So there's something seems to be wrong with the server setup and DNS because I'm getting a connection timeout error, so it's not accepting my request to. So it's either not reaching the URL or when it reaches the URL, it just times out. So something is messed up in the guide where it's not working. But anyways, what we were doing is reading AI Engineering by Chip Huyen. It's the hot new book out right now. So it goes through and explains the current state of engineering. It's a good next step beyond situational awareness by Leopold Aschenbrenner, because Leopold explained what's to come, and this explains how to be a part of what's to come. So, really good book to go on to next. It is more of a just a informational book. It's not a tutorial. It specifically doesn't have any tutorials in it, which I like because whenever I do tutorials, oftentimes they don't work. I mean, see the self-managed network series with Lewis Rossman. I typically can't get tutorials to work. Often the times, in order to get the tutorials to work, you have to pay extra. You have to buy some tool they're selling, or have use AWS, which costs some money, not just the free tier. And then you do the tutorial wrong. You're doing like AWS, you get unexpected charges. So I don't like to just do willy-nilly any tutorial out there. I prefer to just read the information behind it. But I likely will be doing some tutorials eventually. The best tutorials to do came from the book. There's a uh, link I have on part four. Chip Huyen put together a database of all the open source tools out there. So if you want to do a tutorial, and I'll likely this will probably be the first thing I do after I finish the book. Just go in, add a condition to the filter, and then you're gonna filter out by category, and then you're gonna select tutorials. And now, since you did that, you can see you can filter it by stars. So how many people, and remember, these people that are starring these, these are all the stars in the field. So you're doing the same thing other people are doing who are working these jobs. So like if you're on an interview and you tell your hiring manager you did all these, they're going to be only 60,000 people did that. So how many people are going to apply? It's like they're probably going to be impressed by doing these tutorials specifically because they're well known, especially if they're aware of this book by Chip Huyen, which they probably are. So if you read this whole book, if you do these tutorials, I'd say start applying for AI engineering roles because you read the book, you did the tutorials. Like the hiring manager is probably going to like what you did. So that's pro. I think that's my plan for sure. And unfortunately, the full link isn't there, but it's just as simple as searching Google for it. And then if it takes you to like a kind of jailed site like this, you can you can also just plug it right into the GitHub link. So you can do github.com. Oops, and my clipboard wasn't right, but you just put that in there, and now you get the tutorial. All right, so those are the next steps for now. I'm just gonna focus on continuing reading text. So I'll pause it and be right back. All right, I'm back, and I just want to say one quick thing about the self-managed network series again, um, which isn't relevant for this, so I probably shouldn't. But I think I know what the answer is to why it's not working. I think he never gave instructions for how to forward a port on your router you received from your oh um, yeah, from your ISP. But that's neither here nor there. It's not related to this. Nobody's watching this for that other series. So let's stay on topic here and move on to hallucination. Hallucinations are fatal for tasks that depend on factuality. If you're asking AI to help you explain the pros and cons of a vaccine, you don't want the AI to be pseudoscientific. True. In noon, at noon, so in June 2023, a law firm was fined for submitting fictitious legal research to court. They had used ChatGPT to prepare their case, unaware of ChatGPT's tendency to hallucinate. And I have a lot more. I'm biting my tongue here because I have so much to say about this. Um, all right. So let's keep reading and then I'll give some commentary on this because I have a lot to say about this. While hallucination became a prominent issue with the rise of LLMs, hallucination was a common phenomenon for generative models even before the term foundation model and the transformer architecture were introduced. Hallucination in the context of text generation was mentioned as early as 2016. Detecting and measuring hallucinations has been a staple in natural language generation (NLG) since then. This section focuses on explaining why hallucinations happen, how to detect and measure evaluation is discussed in chapter 4. All right, so I think now is a good time to give a little bit of commentary about that. Um, so the first thing I'll say is um, humans hallucinate. Like ideally, you know, there's a lot of common pitfalls that humans fall into when it comes to like these people at the law firm. They passed the bar, they passed the LSAT, but they obviously failed. You know, um, uh, ethics and morals or whatever because and they failed just like basic critical thinking because they just took ChatGPT's word for it. But the average person hallucinates like, and I'm not even talking about dementia. It's like ideally you would say I don't know, but like a lot of people are taught by their jobs that I don't know is like the worst thing you can say, whereas like scientifically minded, like it's like the best thing you can say, and then design an experiment, a hypothesis, to figure it out. So like I don't think this makes AI uh, worse that it hallucinates. I think it just requires more sophistication by the user. But it definitely does lead to more pitfalls. So detecting and measuring it and mitigating it is super important for sure. The other thing I want to say about that is in my own usage, I found that hallucination hasn't been really that destructive. It's actually like possible for AIs to hallucinate in a way that's useful because I cross-check most of what AI puts out there. So like if I ask AI to like tell me a fact about the Bach chorales and like it hallucinates, like I'm gonna try to like first of all I have like a little bit of knowledge to begin with. So like if it really hallucinates, I'll be like, oh no way. And then second of all, like I'm going to like if I really need to use it, like I'm going to cross-reference it. I'm gonna like listen to it myself and like I'm not going to just take ChatGPT's word for it, and I'm really surprised that a law firm would be the one to do that. So I don't know. It just kind of says a lot about this law firm that they would just in 2023 as soon as it came out when it was kind of a clunker, um, that they would just take ChatGPT's word for it. Yeah, is this an employee at the law firm?
And kisses you deeply. See, now here's where things could heat up.
A new class of AI has been unleashed.
Nobody had any idea that like 100 million people would start using these things. And nobody really has a full sense of what that's going to mean, either on the plus.
All right, I'm not gonna watch this whole thing. It's 22 minutes. Yeah, but yeah, an aviation injury claim. I mean, that's just ridiculous. Like, and then the thing is, like nowadays, and I wanted to make a whole video on this. Like, you can just use operator. So you can say you can go to operator, which I now have access to, and I'm going to say, help me do research for an aviation injury claim. There. And now, so now it's opening the browser, so you can open this up, and it's no longer hallucinating. Right now what it's doing is it's googling it, which is what I would do anyway. Now the problem is when it googles it, well, it's not googling it; it's binging it. But the problem is a lot of what you see is AI generated nowadays when you search for something in a search engine. But there we go. Adamson, Adote. I mean, this seems fair. This is all about aviation accidents by an actual law firm. This could be generated by ChatGPT, but it's a good start, I think. So like we come a long ways for sure, but I mean so I'm worried uh about including wrong information in my uh research. Can you please stick to the actual laws if you can find them? Some opinion, some research from sites like you're looking at will be fine, but yeah. We'll just do this. See, and now it's going to change up its strategy, and instead of going to leaday.co.u, personal injury blog, I want it to go to the actual law. And it's clever. Operator's clever. It can try things that you would never think of trying to go out and get to the real law. So we can see it's changing up its strategy now. It's looking for the actual laws. So aviation injury claim laws, and it probably needs to know what state I'm in. So here we go. Here's a guide to. So I'll probably get right to the place where you submit the claims, the first-hand source. I mean, you could just say like focus on primary sources. Yeah, there we go. Site colon dot gov. See, now it's looking at government sites that publicly post what the law actually is, rather than the blog posts by the engineers. So I would say now is not the time to be afraid of ChatGPT, especially with Operator. You just have to use it right. And if you're following this series, reading this book, you're probably ahead of the game. But it is a fair warning to say that a law firm, used it improperly. And then, that was very early on in ChatGPT history. So the expectation that you could use it in legal research was probably not fair to make. But look at this. This is the actual law from FAA, Federal Aviation Administration.gov. So we're looking at tort part 9. Now we're looking at GPO.gov. We're looking at just the main page. We're searching for a specific part of the law we're interested in. We're interested in 28 CFR Part 1. So we're trying to pull that up right now using the search function. Now we're in govinfo.gov, searching for part 14, 28 CFR Part 14. That seems like it's relevant. Uh, and look at this. We got primary sources, so we don't have to worry about hallucination in the same way we used to because of operator. So because we're looking at the primary sources, we're going to use these primary sources in our research. We're not going to. The only thing that can hallucinate here is these outputs here. But at any time, I can take control and I can um, use this in my research. I can look at these. I can tell it to give me back so I can say that URL looks interesting. Give it back, print it out here, please. Let's do that. So that URL looks like you're on track. That website looks interesting. We'll just leave it work. But at any time you can have it spit that out to you, and that's what goes in your research. So we're in a different world. This thing, as I've said in my series with Leopold Aschenbrenner, um, the we're in a this is going to increase by two full orders of magnitude by like 2027. So it hasn't even finished increasing by a full order of magnitude yet, and it can already do like look at this. This is the actual CFR 2023 Title 28 Volume 1. Um, and this is the Federal Tort Claims Act. Um, so this is for the recover actions for the recovery of medical expenses. This is like, boom, look at that. Operator is awesome, to say the least. And it's just going to get better. All right, so I'll just I'll leave it up without pausing it, just so seeing that work can go a bit more. I need to scoop myself up some supplements quick here. Creatine and saffron. Should be okay. All right. Okay, so there we go. Look at that. Okay, so now it's stalled out there. So give me a moment here, and I will look at that. Okay, so I found the regulations for filing an administrative claim under the Federal Tort Claims Act, specifically 28 CFR Part 14. So if it would hallucinate, we wouldn't see this page. We've got it right here, which outlines procedures and requirements for representing claims. The information includes details on submitting claims, coordinating between agencies, and handling multi-agency involvement. So what a world we live in, man. Like it's not the same. So that's all I needed to go on a tangent there because anytime hallucination is brought up, I think it's a really important concern, and I think it needs to get better. But I think the instance of this law firm being fined for submitting fictitious legal research to court reflects more poorly on the law firm than on ChatGPT. It's gonna hallucinate. People hallucinate. Like you have to use it now. If the law firm had a full time staff AI engineer that did the research using the tool, and then they did that, then yeah, that AI engineer should be fired and fined because that would be um, then I would agree that but even then, it's like it's useful even with the hallucination, in my opinion, if you use it properly. If inconsistency arises, and one final thing to say, in the world of operator, which we're in now, like it'll give you its links, like you'll see what it's doing. If inconsistency arises from randomness in the sampling process, the cause of hallucination is more nuanced. The sampling process alone doesn't sufficiently explain it. A model samples outputs from all probable options. But how does something never seen before become a probable option? The model can output something that is believed to have never been seen before in the training data. We can't say this for sure because it's impossible to comb through the training data to verify whether it contains an idea. Our ability to construct something so complex that we can no longer understand it is both a blessing and a curse. It's hard to devise a way to eliminate hallucinations without understanding why hallucinations occur in the first place. There are currently two hypotheses about why language models hallucinate. The first hypothesis, originally expressed by Ortega et al. At DeepMind in 2021, is that a language model hallucinates because it can't differentiate between the data it's given and the data it generates. Let's go through an example to illustrate this. Imagine that you give the model the prompt, "Who's Chip Huyen?" The first sentence in the model, the first sentence the model generates is Chip Huyen is an architect. The next token the model generates will be conditioned on the sequence. Who's Chip Huyen? Chip Huyen is an architect. The model treats Chip Huyen as an architect. The model treats Chip Huyen as an architect, something it produced, the same way it treats a fact. Starting with a generated sequence slightly out of the ordinary, the model can expand upon it and generate outrageously wrong facts. Ortega and the other authors created hallucinations, called hallucinations, a form of self-delusion. Figure 2-24 shows an example of self-delusion by the model Lava v1.5, 5, 1.5-7b. I asked the model to identify ingredients listed on the product's label in the image, which is a bottle of shampoo. In its response, the model convinces itself that the product in the image is a bottle of milk, and then continues to include milk in the list of ingredients extracted from the product's label because it can basically poison itself by having a word be involved and then not being able to get rid of that word from its responses. So the prompt is read the exact ingredients used in this product from the label provided. So the product is a bottle of milk. The label provides the following information. So milk, and then even things like protein. So it can't read it because it's snowballing hallucinations. So Zhang et al. In 2023. So 2024 was an example of self-delusion by Lava V1.57b. Zhang et al. In 2023 called this phenomenon snowballing hallucinations. After making an incorrect assumption, a model can continue hallucinating to justify the initial wrong assumption. Interestingly, the authors show that initial wrong assumptions can cause the model to make mistakes on questions it would otherwise be able to answer correctly, as shown in figure 2-25. So, is 9677 a prime number? No, 9677 is not a prime number, which is incorrect. It can be factored into 13 and 745 as 13, but so it hallucinated that 13 times 745 for someone like me who's uh, filled by the educational system for even how to use a calculator, let alone the fact that I'm using it in the first place. So it's 9,685. Wrong answer. Is 9677 divisible by 13? In a separate session, ChatGPT 4 recognizes its claim as incorrect. So no. So that's figure dash 2-25. An initial incorrect assumption can cause the model to claim that 9,677 is divisible by 13, even if it knows this isn't true. The DeepMind paper showed that hallucinations can be mitigated by two techniques. The first technique comes from reinforcement learning, in which the model is made to differentiate between user-provided prompts, called observations about the world in reinforcement learning, and tokens generated by the model, called the model's actions. The second technique leans on supervised learning, in which factual and counterfactual signals are included in the training data. The second hypothesis is that hallucination is caused by the mismatch between the model's internal knowledge and the labeler's internal knowledge. This view was first argued by Leo Gao, an OpenAI researcher. During SFT, which remember stands for something fine tuning, I don't remember what the S stands for. Models are trained to mimic responses written by labelers. If these responses use the knowledge that the labelers have, but the model doesn't have, we're effectively teaching the model to hallucinate. In theory, if labelers can, that bothers me that I don't know that. Let's just get a quick answer from 4.0. In the sorry. Hey, damn it, wrong button. In the context of AI engineering, what does SFT stand for? I'm pretty sure, sorry, SFT. There are typos, but hopefully you understand. I'm asking what the acronym SFT stands for. I'm pretty sure that the F and the T stands for fine tuning. Supervised fine tuning. I think that's right. And this is where, you gotta, if you completely rely on that answer, you're not using it properly. So you can cross-reference it. There we go. Hugging Face. What better source is there out there than Hugging Face? So supervised fine tuning. So during supervised fine tuning, models are trained to mimic responses written by labelers. If these responses use the knowledge that the labelers have, but the model doesn't have, we're effectively teaching the model to hallucinate. In theory, if labelers can include the knowledge they use with each response they write, so that the model knows that the responses aren't made up. We can perhaps teach the model to use only what it knows. However, this is impossible in practice. In April 2023, John Schulman, an OpenAI co-founder, expressed the same view in his UC Berkeley talk. Schulman also believes that LLMs know if they know something, which in itself is a big claim. Yeah, what's the mechanism for that? If this belief is true, hallucinations can be fixed by forcing a model to give answers based only on the information it knows. He proposed two solutions. One is verification. For each response, ask the model to retrieve the sources it bases this response on. Another is to use reinforcement learning. Remember that the reward model is trained using only comparisons. Response A is better than response B without an explanation of why A is better. Schulman argued that a better reward function that punishes a model more for making things up can help mitigate hallucinations. In that same talk, Schulman mentioned that OpenAI found that reinforcement learning from human feedback helps with reducing hallucinations. However, the Instruct GPT paper shows that RLHF made hallucination worse, as shown in Figure 2-26. Even though RLHF seemed to worsen hallucinations for Instruct GPT, it improved other aspects, and overall human labelers prefer the RLHF model over the SFT alone model. All right, so this is figure 2-26. Hallucination is worse for the model that uses both RLHF and supervised fine-tuning, Instruct GPT, compared to the same model that only uses supervised fine-tuning. So we've got four models here: real toxicity, truthful QA, uh, Oh, no. So we've got four data sets here. The first data set is the real toxicity data set, then the truthful QA data set, then hallucinations data set, and then the customer assistant appropriate data set. So this is all data that uh, appears to determine whether or not it is responding in a toxic way, a truthful way, whether or not it's hallucinating, and whether or not it is responding in a way useful to assist a customer. Evaluating Instruct GPT for toxicity, truthfulness, and appropriateness. Lower scores are better for toxicity and hallucinations, and higher scores are better for truthful QA and appropriateness. Hallucinations and appropriateness are measured on our API prompt distribution. Results are combined across model sizes. So, okay, so you want it not to be toxic, of course. So GPT on its own, without any extra fine tuning, is uh, quite toxic and it hallucinates quite a bit, it looks like. But once you add those, oh, but yeah, see, it hallucinates more um, when you apply both RLHF and supervised fine tuning, as is done in Instruct GPT. But when you just do supervised fine tuning, the hallucinations go way down. The toxicity is about the same, a little bit more. Um, the it also yeah, but the truthfulness goes way up, which is important, and then the appropriateness to a customer goes up as well in what looks like a somewhat significant way. But the hallucinations go up quite a bit. Based on the assumption that a foundation model knows what it knows, some people try to reduce hallucination with prompts, such as adding answer as truthfully as possible, and if you're unsure of an answer, say, sorry, I don't know. Asking models for concise responses also seems to help with hallucinations. The fewer tokens a model has to generate, the less chance it has to make things up. Prompting and context construction techniques in chapters 5 and 6 can also help mitigate hallucinations. The two hypotheses discussed complement each other. The self-delusion hypothesis focuses on how self-supervision causes hallucinations, whereas the mismatched internal knowledge hypothesis focuses on how supervision causes hallucinations. If we can't stop hallucinations altogether, can we at least detect when a model hallucinates so that we won't serve those hallucinated responses to users? Well, detecting hallucinations isn't that straightforward either. Think about how hard it is for us to detect when another human is lying or making things up. But people have tried. We discuss how to detect and measure hallucinations in Chapter 4. Summary. This chapter focused on the core design decisions when building a foundation model. Since most people will be using ready-made foundation models instead of training one from scratch, I skipped the nitty-gritty training details in favor of modeling factors to help you determine what models to use and how to use them. And remember, this book is about teaching you AI engineering. It's not teaching you ML engineering. And a clear way you can think about the difference between the two is ML engineering is the engineering that occurs during the training of the model, and AI engineering is the engineering that occurs after the model has already been trained. And for most people in this world, the one that is accessible and relevant is going to be AI engineering rather than ML engineering, because training these models, they set up 3 Mile Island again. They're using nuclear powered data centers. They're not going to just let a person work on training these models. Like that's what's probably going to be locked down through the as Leopold Aschenbrenner called it, I forget what he called, but called it exactly the project, I think is what he called it. So when governments take over this and don't allow the average person to have it the way they do with nuclear weapons, if you start building a nuke and making progress on it, the FBI is going to knock on your door. Once they adopt that attitude towards um, AI, it's all over when it comes to working on machine learning, building and training models. And even without that attitude, do you have a 10 gigawatt data center? No. So like you're going to get the most bang for your buck by focusing on that other side, using these models as they come out, following the Hugging Face leaderboard. Um, and then being able to take these models off the leaderboard and using them for things. Training your own model is kind of a skill that it's valuable. I mean, if you can go to school for that and get a PhD in that, oh man, you can get a good job doing that for sure. But you'll be working for one of these big companies, or you'll be working for the government. If you just want to use AI in your own life, um, or if you want to have a wider diversity of employers you can work for, big and small businesses, that other side using the models after they've already been trained is where you'll get more bang for your buck. But I mean, if you want to be like an AI AI professional and like be one of the most respected people out there in AI, then yeah, focusing on that ML side makes sense. But it's not going to be as you're not really going to be able to implement a lot of what you study. A crucial factor affecting a model's performance is its training data. Large models require a large amount of training data, which can be expensive and time consuming to acquire. Model providers therefore often leverage whatever data is available. This leads to models that can perform well on the many tasks present in the training data, which may not include the specific task you want. This chapter went over why it's often necessary to curate training data to develop models targeting specific languages, especially low resource languages and specific domains. After sourcing the data, model development can begin. While model training often dominates the headlines, an important step prior to that is architecting the model. The chapter looked into modeling choices such as model architecture and model size. The dominating architecture for language-based foundation models is Transformer. This chapter explored the problems that the Transformer architecture was designed to address, as well as its limitations. The scale of a model can be measured by three key numbers: the number of parameters, the number of remaining tokens, and the number of flops needed for training. Two aspects that influence the amount of compute needed to train a model are the model size and the data size. The scaling law helps determine the optimal number of parameters and number of tokens given a compute budget. This chapter also looked at scaling bottlenecks. Currently, scaling up a model generally makes it better. But how long will this continue to be true? Due to low quality of training data and self-supervision during pre-training, the resulting model might produce outputs that don't align with what users want. This is addressed by post-training, which consists of two steps: supervised fine-tuning and preference fine-tuning. Human preference is diverse and impossible to capture in a single mathematical formula, so existing solutions are far from foolproof. This chapter also covered one of my favorite topics: sampling, the process by which a model generates output tokens. Sampling makes AI models probabilistic. This probabilistic nature is what makes models like ChatGPT and Gemini great for creative tasks and fun to talk to. However, this probabilistic nature also causes inconsistency and hallucinations. Working with AI models requires building your workflows around their probabilistic nature. The rest of this book will explore how to make AI engineering, if not deterministic, at least systematic. The first step toward systematic AI engineering is to establish a solid evaluation pipeline to help detect failures and unexpected changes. Evaluation for foundation models is so crucial that I dedicated two chapters to it, starting with the next chapter. All right, so here's all of the footnotes, or the citations rather, not the footnotes. These are the citations. So I'm just going to skim these. I'm not going to read all of these out loud. And some of them we already did look at. If they were interesting enough, we just skimmed. We just uh, skipped right to it. This one is interesting. A list of secret websites that make it sound smart. I don't know what that means. Oh, it's behind a paywall. So okay, so she's writing about Ilya Sutskever here, and I will say this book did something really dishonest that was kind of upsetting to me. It basically did like a "and you can too" sort of thing, where like it's like why should you study ML engineering? Oh, because Ilya Sutskever was so successful in it. Maybe you should. Maybe you'll be successful in it too. Ilya Sutskever started college when he was 13, and he's wrote some of the foundation research papers. He's a unique person with a unique, like, he's lived in like multiple countries. He speaks multiple languages. Like Ilya Sutskever is not someone you can look at and say, oh, he did it, so I can do it. So that's not to say that you know you're not the next Ilya Sutskever, but it is to say to choose your path wisely. And just because Ilya Sutskever did it doesn't mean that you can do it too. It's like saying, oh well, Einstein made uh, advances in physics. Maybe I should become a physicist. It's like if you're questioning whether or not you should become a physicist, you shouldn't become a physicist. Einstein did not ever question whether or not he wanted to be a physicist. As far as I know, I don't know. Maybe he did. Okay, so yeah, just skimming these, not going to read these out loud. I'll make some comments, perhaps at my detriment, uh, as I did about Ilya Sutskever, if I see anything that strikes me as interesting. There are a lot of, and these are footnotes and citations. Oh, this is interesting. So this talks about the author's professional experience. In December 2023, I went over 3 months worth of customer support requests for an AI company I advised. So she worked as an advisor for an AI company, which a lot of people work at McDonald's when they okay, and found that 1/5 of the questions were about handling the inconsistency of AI. Maybe the AI company was McDonald's of AI models in a I'd say that not I'm joking when I say that, but like I think we're gonna see AI at McDonald's if it's not there already. AI is going to be everywhere in the next few years if it's not there already. In a panel I participated in with Drew Houston, CEO of Dropbox, and Harrison Chase, CEO of LangChain, in 2023. We all agreed that hallucination is the biggest blocker for many AI enterprise use cases. Yeah, the last thing you want is, imagine stock trading, right? It's like, oh, what's the price of the stock today? It just hallucinates a stock price. Like, no, no, thank you. So it makes a buy sell decision based on just its own hallucination of the stock price. No, no, thank you. I'll pass. Well, anyway, that's it for chapter two. Stay tuned for the start of chapter three.